Yo, hi everyone. It's like 5 a.m. I'm like dead inside, but hey, let's get started. Um, when I was in J1 or like J2 or like sometime then, I came up with this thing called Essential OOP, which is like an IPY&B that taught you everything about object-oriented programming. Because my friends were kind of low-key a bit lazy to read notes. And also the notes didn't have examples you could directly interact with. So here we have kind of me explaining essential OOP so that you can use this document in a more useful way. So for context, I'm probably going to put this up on my GitHub. I'll leave like a bunch of links to this. There's also a Google Drive folder which I can link. And then like I tried to get this out there as much as possible. I'll just link as much stuff as I can. So yeah, object-oriented programming is just programming that allows you to not repeat yourself. That's the best way to think about it. In regular programming, a lot of the time, when you do things that make your code clean, you end up writing more than necessary. And object-oriented programming is a framework that's supposed to reduce that. So let's get right into it. A class, you can think of it as like a blueprint. Kind of like, a blueprint actually. If I wanted to, for example, create a bunch of microphones, right? I would use a blueprint, a class, and then create as many microphones as I want, or objects. But you have to understand that the class itself is not an object. You can't look at the blueprint of a microphone and speak into it and expect other people to hear you. So yeah, that's the difference between a class and an object. So for your class, you would have to write it this way, class and then VJ student, for example. And then you have to come up with your constructor, I guess. In this case, this is just what you use to provide values to your object. So in this case, what this is saying is when this object is created, when an object is created from this class, right? Make sure that they can input the name and store it as self.name. Most of your variables will be self.variables, which are variables specific to the object itself. So let's say my class is a bunch of different students, right? In this case, the object I create itself will be, in this case, Josh. And Josh himself will have a variable called name. If I have another friend called, like, let's say Ryan, he has a name as well. The variable is also called name for him, but they are both different variables even though they have the same name because they belong to different people. Same thing over here. Different variables belong to different instantiations of the same class because they're different objects. So that's kind of how you would go about doing this. This is saying when you call VJ student to create an object, right? Use the blueprint and take a name, right? Which they pass in and add it to whatever the individual object wants as their .name, self.name. So yeah, when you want to read from a class and object, right? Basically, it's a similar thing over here. Def underscore underscore str underscore underscore. You basically use that as a way for your object to kind of read itself out to everyone, announce it itself. So all you need to do is call the object itself in your print, and then it'll kind of give you whatever's in the underscore underscore str. Honestly, they can't test you on this. I've seen it happen before, so keep your eyes peeled. You might have to replicate this. But both init and str should be provided to you in your insert, so just watch out for that. Okay, next up we have encapsulation. So encapsulation is not as hard as it seems, actually. It is just the idea of using public routines to access private variables. How does this work exactly? Well, let's say we have self.name and self.height as we've defined over here, right? In this, right, you can't exactly just set those values. Like if, for example, Josh was initialized, right? And I wanted to change his name. I can't just go and be like, Josh.name change or like whatever. You need to use a setter or getter method, which you have to create for yourself based on the class itself. This is for you to use. And the reason why you'll get denied is because you don't have the permission, in a sense, you don't have the right, the authority to make changes to an object that's been initialized. The only person who has the authority to do that is a child of the object itself. So, if you yourself want to go and change the height or the whatever, you have to create a set and get method. So yeah, this is how you would end up doing it. A get method is very simple. It just returns the value. And the set method, well, I guess you just need to pass in a variable called height, then self.height, which refers to the self.height over here. You just set it to whatever height's been passed through. It's basically the same as init, except in this case, usually you would put down something that says like print, Josh has grown or shrunk or whatever. So yeah, set height and get height, setter and getter are really, really simple, and they effectively don't do anything special, but you need them because you need a function to belong to VJ student, such that if you use it, you won't get screamed at by the computer. Yeah. So that's encapsulation. Now for inheritance. Inheritance is basically when you have attributes and methods being passed down. So let's say we have person. Every person has a name and a phone number, right? Every teacher also has a name and a phone number because they are a person. But they also have a department because they teach in a school. However, other people, normal civilians, don't have a department because they don't teach in a school. So if I have a teacher, right, and I want to specify that this person's a teacher, I could end up creating a whole separate class called teacher with name, number, and department. Or I could just make teacher inherit name and number from person, which again reduces the amount of code you write and makes it easier to troubleshoot. So how exactly do you do that? Again, very simple class, you just declare person. Now, inside of your initialization for teacher, right, you put name, number, and department. And when you do that, you need to initialize person with name and number. So what this does is it takes the values from teacher, right? And for name and number, you immediately pass them into person and initialize person. And for department, you then set a value to it for teacher itself. So self.dept belongs to teacher because teacher is a teacher, but self.name and self.number belong to the teacher because the teacher inherits from person. Yeah, then after that we have the most odd one of the lot, which is polymorphism. Polymorphism is just redefining methods from the parent class in the child class. So let's say, for example, you and your everyone else in your class, the average VJ student, for example, to de-stress, maybe they go to an event, maybe they go to a concert, right? So self.de-stress would be concert. But for you, let's say you're one of the few who don't like concerts at all. You'd rather sit in the library and read a book. In this case, your self.de-stress would be a completely different function, right? Even though it has the same name. Because you are special. You do something different. You're not like other VJ students. Oh my god, I can't believe I just said that. Okay, so when you have a child, right, who wants to do the exact same function with the exact same name, you can redeclare the function to do something different. In this case, def say hello prints out, hey, I'm a person called, and then whatever. But for a teacher, what if they want to say, hi, I'm a teacher instead? In this case, you can have the exact same function, right? The exact same function with all of the stuff inherited, but by redeclaring it, even though you've already initialized the base class, by redeclaring it, you have created a new definition to what the function does, if that makes sense. So instead of saying, hey, I'm a person called, now you're saying, override that actually. Now, for all teachers, they'll say, hey, I'm a teacher called. So there is another way you can do this, using super, which is shown over here. So super kind of just allows you to neglect self, which is the self that you declare over here. Sorry, the self you input over here. It just allows you to not use that. And I guess it saves a bit of time, and it's just a use case thing. But yeah, you have to know that this exists. And yeah, this is how you'd use it. Declare a person called Itadori, a teacher called Rizwan, as Mr. Rizwan, and a student called Josh. And after that, yeah, you can put say hello for all of them, and it'll show you the different say hellos that exist for each of them, as they all override the base class of person for teacher and student, not Itadori, because he's just a regular civilian, right? So yeah, I hope you enjoyed Essential OOP. All the best for your A's, I guess. I don't have much advice to give you for this video, so just have fun. Don't overcomplicate it, and please draw diagrams if it helps you visualize. Okay, bye-bye.